Hi guys, we're doing section 7.2 and 7.3 today. We're going to put them together. So we'll be skipping around a little bit. We'll be skipping some things and jumping around. So what I'm actually going to have you do is start on section 7.2. We will come back to page 107, but I want us to start on page 108 at the bottom. What you should see is this. We talked a little bit about factoring. We did for work once or twice, so you should be very familiar with it. I know you did it in Algebra 1. Let's go ahead and walk through the first one together, and then I'll give you time to try the rest. Factor, then check by multiplying to show your work. If the a term, which is in front of the x squared, is 1, which is why you don't see it, it's usually a much easier factoring problem. You only have to consider things that multiply to 14. 1 and 14, 2 and 7. Because the only things that multiply to 1 are 1 and 1, that's why it's a lot easier in that case. So we think about our factors. We know it's 1x and 1x, which again, you don't normally write the 1, it's usually just x and x. So what are we going to do to get 9? 1 and 14 could never add to 9. 2 and 7 could add to 9 if they're both positive. So we're going to have a positive 2 and a positive 7. This is my answer. I'm going to check it by multiplying. So let me distribute the x. That's going to give me x squared. That's going to give me 7x, 2x, 14. Combine that, x squared plus 9x plus 14. Make sure you don't circle this. That's what we started with. You want to circle your factors. There are two factors. They are x plus 2 and x plus 7. So go ahead and pause the video and try C, D, and E. Here are your answers for C, D, and E. For C, it's going to be x minus 10, x plus 3, and of course that could be in the opposite order, x plus 3 first, x minus 10, but remember the 10 has to be negative, the 3 has to be positive, you can't flip that around. For D, your answer is x minus 6 times x minus 6, which we commonly write as x minus 6 squared. I will not take off if you write it this way, but usually you'll see it written that way. E. So let me help you with E in case you got stuck on E, and then I'll give you time to do the rest. For E, think of this, if it helps you, as x squared plus 0x minus 144, because that's really what it is. There's still an A term of 1, a B term of 0, and a C term of negative 144. So we know that it's going to be x times x because the A term is 1. So we have to think of things that multiply to 144 that add to 0. Well, I'm not going to list them all, but I know that 12 times 12 is 144, and I can get a 0 out of 12 and 12 if one is positive and one is negative. So that's going to be x plus 12, x minus 12. And if you want, you can redistribute that out to make sure you got it correct. Now, if you want to try F without any help first, go for it. Otherwise, I will go through it now. So here our A term is 5. So that means it's not just going to be x and x. It's going to be things that multiply to 5, which are 5 and 1. Now think of things that multiply to 75. So there's quite a few of them. Let's see, 1 and 75. Actually, you know what? These numbers are so big, I didn't notice at first. There's a GCF. Let's start with that. Everything here has a 5. So why don't we factor out a 5 first? Now I can continue to factor. Now I do have an A term of 1. That 5 on the front will just tag along. That's just being multiplied. Think of things that multiply to 15. Add to 8, so the 5 and the 3. So these are my factors. There are 3 factors. To check my work, I might just distribute this onto this, and when I'm done, I'll multiply that answer by 5. If there was not a GCF, like let's say this was 76, then you would have 5 and 1, and then you would have to write out all the multiples of 76, try them here and here. If they don't work, flip them until you find the right one. And if there isn't one, then it's not factorable. Okay. Letter G, there is a GCF here. So what is the largest thing they have in common? Try 12. They do have a 12 in common. Now I know they don't both have a negative, but it's nice to have your A term be positive. So I'm going to take out a negative and a 12. So when I divide this by negative 12, I get x squared. You might say, how do I take a negative out of this? We'll take 108 divided by negative 12. You get negative 9. Now let's factor that further. Remember, this is the same as x squared plus 0x's minus 9. So what multiplies to negative 9 and adds to 0? Positive 3 and a negative 3. Those are my factors. All right, so now let's go ahead and go back to the very beginning. So page 107. It says in the previous lesson, you had the function a of L, so that was the area in terms of the length, negative L squared plus 50L to model the area in square feet of a rectangle that can be enclosed by 100 yards of fence. Let's jump to, number 1. What are the dimensions of a rectangle if its area is 525? So since this is the area, what we're going to do is we're going to put it right there. So we're going to put 525 equals negative L squared plus 50L. Now, if you look back at your graph, you might be able to tell when it has a height of 525 or your table, but let's say you don't have that. So we're actually not going to find the answer yet until we do part 2. I guess you could look back and find the answer based on your table, but let's do it algebraically. Let's say we don't have a table, it just asks us this question, which takes us into number 2. One way to find the dimensions of a rectangle is to solve the quadratic equation algebraically. Write a quadratic equation you could use to solve it. So that's the same thing. We'll go ahead and get our answer and write it down under number 1 when we're done. Now, you'll notice we've done some problems already with factoring, but they've all had a 0 on one side, or they've just all been next to each other. So let's move the 525 over. Now we haven't worked too much with an equal sign yet, but we will. So I want that 525 to be with the other side. Now from here, let's go ahead and factor. So let's divide by a negative on both sides. That way we can get rid of the negative on the A term. So 0 divided by negative 1 is still 0. L squared minus 50L plus 525. Now let's try to factor that. Hopefully you have enough room on your paper. So I know 525 is a large number, so go ahead and start thinking of things that multiply to 525. Might want to pause the video. Find 2 numbers that multiply to 525 that add to negative 50. You're going to get 35 and 15. 35 times 15 is 525. If they're both negative, they add to negative 50. And if they're both negative, they still make a positive 525. So our factors are going to be L minus 35 and L minus 15. Now, here's the part where we're going to kind of get into section 7.3. 7.2 is more factoring, which we started with those first 6 just regular factoring problems. If you have two factors and you have a 0 on one side, we're going to do what's called zero product property. And this is something you've done in Algebra 1, zero product property. Here's how let me take a pause here for a second to introduce something to you. Here's the way I always teach this. I usually say, okay, I want everybody to figure out the answer to this problem I'm going to write as fast as you can without a calculator. Okay, so do this in your head as fast as you can without a calculator. What's the answer? The answer is 0, because look, if I have a 0 in there and I'm multiplying, I'm going to get 0. So zero product property says if I am multiplying and I have a 0 in there, my answer will be 0. Could I have more than one 0 in here? Sure, my answer is still 0. What if I had a plus sign? Then will my answer be 0? No, this part would be 0, but my answer would be 12. So 2 things have to happen. It's called zero product property. So 0, it has to be equal to 0, and everything has to be a product or a multiple. And if that's happening, let me erase this one. If that's true, then one of these items or more has to be 0. That's what the zero product property says. If my answer is 0 and I am multiplying, one of the things being multiplied has to be 0, maybe more than one. So let's go back here. You'll see that's exactly what is happening. Here's the 0. Here's the product or the multiplication, which means this or this has to be 0, or maybe both. So let's set this first one equal to 0. And let's set this one equal to 0. Solve for L, pretty quick and easy. L is 35. Or L is 15. Remember, that was length. I think it was in inches, but you can, oh no, feet. I think you can look back to check. So again, section 7.2 is more about factoring. Section 7.3 is if my factors are equal to 0, then one of these or more has to be 0. So we set each piece equal to 0, and that can give us our answer. I could plug that in. If I go up to the top where we wrote the problem, let's see, my answer is 35. I could plug in a 35 right here, and I should get 525. Or I could do it in this one here. I could plug it in here and here to check it. So this is why we use factoring. It can help us solve a lot of problems so that I don't have to graph this or make a table. Or maybe my graphic table doesn't even come out to 525. It wasn't one I guessed and I can't find it exactly. This will help me find every answer that I want. You'll see on the top of page 108, maybe you learned using factor boxes. Don't worry about that. As long as you can factor, as long as you can do the bottom part, I don't care. These that we did, B through G on page 108. I don't care how you do it. So if you like the way they did example A, you can look through that yourself, but you do not have to. Again, the same for what was shown to you on page 109. If you'd like to walk through that, you can. But we're going to go ahead and do A through D on page 110. Like I've been saying, we have done this in Algebra 1, so you should be somewhat familiar with these. They are more difficult than the ones we did earlier in the lesson. So maybe pause the video and give them a try, and then go ahead and pause it, unpause it when you're ready to hear the answers. Here are the answers. Well, let me kind of walk through this in case you forget. So we have things that multiply to 3. Well, that's pretty easy, 3 and 1. But my A term is 10, so it's not just going to be x and x. It's going to be either a 1 and a 10x or a 2 and a 5. So pick a combination you like. Let me try 2 and 5. I'm going to put the 2 here, 5 here. And then I'm going to try 3 and 1. If that doesn't work, I'll flip it around. So 3 and 1. You don't have to draw all 4 arrows. You just have to draw 2 of them, because I can see that this times this is going to give me this, and I can see that last term times last term is going to give me last term. So all I have to draw is 2 arrows to figure out the middle term. And those arrows are the farthest outside, those multiply to 2x. The farthest inside, those multiply to 15x. Can a 2 and a 15 get me an 11? No. So that means the 3 and the 1 in the position I wrote them were not correct. So I'm going to flip the order. I'm going to put the 1 first and then the 3. Let's try it now. That is 6x. These multiply to 5x's. Could 6 and 5 get me 11? Yes, if they're both positive. So these are my factors. If you want to rewrite them neatly, you can. 2x plus 1, 5x plus 3. You can always redistribute to check your work. Okay, so for B, 15 is a 1 and a 15, a 5 and a 3. Check the negative when you're all done. The 4 is either a 4 and a 1 or a 2 and a 2. So again, pick what you want to start with. I usually start with the A term first, so I'm going to go with a 4 and a 1. And I'm going to try 5 and 3. Four times 3, 4x times 3 is 12x. 5 times 1x is 5x. 12 and 5 does make 17. But you'll notice they would both have to be positive to make positive 17. And a positive 5 and a positive 3 won't make negative 15. So while this looks like it's going to work, it will not. It works for the 17. But 5 times 3 is positive 15. So that actually won't work. So I'm going to erase. And since 5 and 3 didn't work, I'm going to flip the order. I'm going to put the 3 first and then the 5. So that's 20x and 3x. That could make 17 if the 3 is negative. If the 3 is negative and this is positive, will that give me negative 15? Yes, it will. Negative 3 and positive 5 makes 15. So these are my 2 factors. If that did not work, what you would want to try is you would want to try 1 and 15 and then flip those around. If that doesn't work, then you know that 4 and 1 doesn't work, and you go to 2 and 2 and try that you find the right one. Okay? The answer for C is 2x minus 7, x minus 3. Give yourself some time to try D. Answer is 2x minus 9, 3x plus 4. Okay, so we're done with 7-2. They're easier factoring problems if the A term is 1. Then there are harder factoring problems if the A term is not 1. Don't forget to always look for a GCF, because that's required that you at some point take out the GCF. It's easier to do it at the beginning, so you get to work with smaller numbers. Now we've already done quite a bit of learning what's going to be in 7-3, so let's jump to page 111. You could look at the example A, but we're going to walk through some. So let's just start together with the bottom of 111. Solve each equation by factoring, show your work. So what we're going to do is we are going to take this side, since it's equal to 0, and factor it. So pause the video and try your factors. Try to find the factors. Okay, so after taking your time to factor those, these are your factors: 4x minus 5, 3x plus 2. Because it's equal to 0, and we have the product, we do zero product property. We set each piece equal to 0. Go ahead and solve each one separately. When you're done, it's always great to show your work. So if I got an answer of 5/4, I plug that in here. Be careful because it's a fraction. Do it in parentheses, and there you should get 0. And then try your answer of -2/3. Okay, go ahead and, I don't know, maybe try as many of these as you can without me showing you the answers, and then unpause it, and I will go over the answers. C, answer. Well, let me show you a little bit of work first. It's going to say your factors are going to be x plus 9, x minus 1. And after I set each piece equal to 0 and solve, I get -9 and 1. For letter D, my factors come out to be 2x plus 3, 2x plus 3. They're the same. That's okay. If I set this equal to 0 and this equal to 0, I'm going to end up getting -3/2 and -3/2. No need to write it or circle it twice. You just say you got an answer of -3/2. It's called a repeated root. We'll get into that much later in the semester. Letter E, there's a GCF here for letter E. So if I factor out a 2 to start working with some smaller numbers, I get 9x minus 49 equals 0. And I'm going to factor this further. So it's going to be 3x plus 7, 3x minus 7. Now you might be wondering, can I still use zero products property here? Yes. I have a 0 here that's equal to, and I have the product. So I'm going to set each piece equal to 0. So 2 equals 0, 3x plus 7 equals 0, 3x minus 7 equals 0. This is going to give me 7/3. This one will give me -7/3. What does this give me? 2 equals 0. That doesn't give me anything. It doesn't mean no solution. It's just there's no zeros or no other x values that I get from that. Okay, go ahead and do F and G. The answers to F are -2 and -4. The answers to G are negative. Actually, let's talk about F real quick. You'll notice it's not equal to 0. First thing you want to do for F is move the 8 over, add 8 to both sides. Then you're going to factor. Now you have zero product property. Set each piece equal to 0. That's how you get -2 and -4. Same goes for G. It's not equal to 0, so you wouldn't be able to use zero product property until you get 0 on one side. So go ahead and maybe pause the video to factor it. Then set each piece equal to 0. My answers are 3/5 and -1. So the next page is kind of going to talk about the area problem again, but instead of going with what that problem says, let me go ahead and go over kind of an overview. So we had an expression of this, -L squared plus 50L. That was our area formula. I could figure out any area I want. I could figure out the length if the area was 215. If I wanted to know what length and what width gives me an area of 215, I could solve this. That would give me the length. Once I have the length, it's a rectangle, so I can find the width. So I can find any area I want. Okay, so that's what's going to happen on the next page. If we look at number 2 on the next page, it says a park has 2 rectangular tennis courts side by side. Combined, the courts have a perimeter of 160 and an area of 1600. Write a quadratic equation that can be used to find L, the length of the court, in yards. So remember, we have a rectangle. We know the area is 1600. So first of all, think about this. Area equals length times width. It's a rectangle. But we don't want this, we don't want 2 different variables. So we're going to figure out how to write W in terms of L. So area is length times something. So let's take a look here. If my perimeter, if this plus this plus this plus this is 160, what would a length and a width be? Those together would be 80, right? So a length and a width have to add to 80 because when I double it, I get 160. So this means that the width is going to be 80 minus L. So over here, instead of W, we don't want a W. We can write this instead of W. Then I could distribute that out. So it's going to look like this. Area equals 80L minus L squared. We even have more information. We know the area is 1600. So I'm going to put a 1600 in here. And I'm going to write this in standard form. Okay, so from here, we're not going to take time in this video, but you could move this to the other side by subtracting 1600 and factor it to find L. Okay, once you have L, you should be able to find your width. Let's go to number 6. Number 6 looks hard because there's a picture. It's not going to be too hard. Number 6, Fence Me In has been asked to install a fence around the cabin. The cabin has a length of 10 yards and a width of 8 yards. There will be a space X yards wide between the cabin and the fence on all sides as shown in the diagram. The area to be enclosed by the fence is 224 yards. All right. Part A, write a quadratic equation that can be used to determine the value of X. We have a rectangle, we have the area. So again, let's write down area equals length times width. I always like to start with what makes sense to me. This makes sense if it's a rectangle, the area is length times width. For area, I know that's 224. And again, I don't want 2 different variables here. So let's call this the length. How do I express this? It's 10 with an X added to it and an X added to it. So what is 10 plus an X plus another X? 10 plus 2X. If this is the width, how would I write the width? That's 8 with an extra X on both sides. So that's 8 plus 2X. That is how you would write a quadratic equation. Now it's not in standard form, so you can distribute out this part, move the 24 over so it's equal to 0. Go ahead and pause the video and work on that. So you can go ahead and go through some of my work here if you want to see it. I distributed out, move the 224 over, so that's equal to 0. Now I noticed that they all have a 4 in common, sorry. So I'm going to divide everything on this side by 4 and divide everything on this side by 4. 0 divided by 4 is 4. Now I have a much smaller problem to factor. So things that multiply to 36 and add to 9 would be 12 and 3. 12 is positive, 3 is negative. Set each piece equal to 0, I get 3 and negative 12. What does x stand for? X stands for this little piece that was added. Well, that piece cannot be negative, so that will not work. So my only answer is x is 3. In this case, I think it's yards. Okay, so again, another way that we use factoring to solve a problem, we can figure out the area. We can find the dimensions if we know the area. All right, last thing is we're going to kind of be working backwards. So let's look together. Again, that's done for you at the bottom of 113, what we're about to do. But we're going to do some together on page 114. Let's look at, actually, let me just walk through what's on 113. It says, example B at the bottom. Write a quadratic equation standard form with the solutions of x equals 4 and x equals negative 5. So you will see a problem that says this on homework or a quiz. You are to write the equation when you know the answers. So we're working backwards. So take a look at what they did. If 4 is an answer, then that means x minus 4 had to be one of the things that was written, because when I solve this for x, I get 4. So it's the opposite. So if 4 is an answer, I'm going to put x minus 4 equals 0. If negative 5 is an answer, I'm going to put x plus 5 equals 0. So that means these are my factors, which it shows you here. And so you're going to write them being multiplied. And you're just going to distribute them out. So x squared plus 5x minus 4x minus 20 simplifies to this. This is your quadratic equation in standard form. Let's look at the next page, part B. Write a quadratic equation in standard form whose solutions are x equals 2/5 and x equals negative 1/2. Actually, I like part C better because one's an integer and one's not. Write any quadratic equation in standard form with integer coefficients for each pair of solutions. So we know what to do with the 2. We write x minus 2 equals 0. We do the opposite. What do I do with this fraction? Do the same thing. X minus 2/3 equals 0. Whatever your solutions are, you're going to put x minus. If it already has a negative, it turns into a positive. So that means these were my factors. So I'm going to write them next to each other because they were multiplied. They were my factors. Now I'm going to distribute that out. X squared negative 2/3 x minus 2x plus 4/3 equals 0. Now I could combine my x's here if I want to. So I have 2 x's that are negative and negative 2/3. So what is negative 2 plus negative 2/3? Well, it's negative 2 and 2/3, but let's write that as one improper fraction. So remember, 2 times 3 is 6, plus 2 more, negative 8/3. You can use a calculator to check it. Now, some of you will stop here. That will give you a lot of points, but it says standard form, which implies integer coefficients. This coefficient is 1. That's an integer. This is not, this 3 right here is not an integer, this 8/3. So we need to get rid of the fractions. That's part of the rules. So let's multiply everything here by 3. We do it to one side, we got to do it to both sides. Well, that side doesn't change anything. So 3x squared minus 8x plus 4. Oops, sorry. Sorry, I think I said it right, but I wrote it wrong. So this should be 0 times 3, of course, is 0, not 3. So this would be my equation. That's my answer because it asked me for a quadratic equation whose answers or solutions are these, and that is what I get. So again, a lot in these sections, but not stuff you haven't done before. So factoring, zero products property when it's equal to 0, and a couple word problems. So go ahead and start your homework. Make sure you're showing your work.